Hey guys, I am Sharat Chandravi. Welcome back to my Ansys tutorial. In this video, I will be showing you how to analyze temperature distribution in a composite wall using Ansys. This is the problem. The exterior wall of building is constructed of 4 materials. Those are gypsum having a thickness 12 mm and 75 mm thick fiberglass, 20 mm thick polywood and 20 mm thick hardboard. The inside and outside air temperatures are 20 degree and minus 10 degree. If you consider this as the inside of the surface and this is the outside, here the temperature is 20 degree, here it is minus 10 degree. The convective heat transfer coefficient of inner and outer surfaces are 6 watt per meter square degree Celsius. This is 10 watt per meter square degree Celsius respectively. Determine the heat flux and temperature distribution. Take conductivity for gypsum, it is 0.176, for fiber 0.036, for polywood 0.115, for hardboard 0.215, and area is 1 meter square. Now let us look into the theoretical solution of this problem. This is the heat transfer 11.1736 and this is the temperature calculated using formula. Now let us compare this using Ansys, and you can find this document in the description below and you can download it from there. Now let us solve this using Ansys. Click on mechanical APDL icon, you will get this window open. Click on preferences, thermal, H method, OK, preprocessor, element type, add, link. Here you have to select or create both these elements, that is conduction and convection, since the conduction and convection are taking place on the wall. To create the conduction element, click on 3D conduction 33 and make sure element type reference number is 1 for the conduction and click OK. Again click on add, we have to create the convective element, therefore select convection 34 and here the reference number should be 2 and click OK. Now close this. Now we have created the two elements, that is conduction element and convection element. We have to assign the real constant for both the elements. So click on real constants, add. For the first element, that is link 33, click on it and click OK and give the area value, that is 1. It's 1 meter square and close this. Now again click on add. For link 34, that is convective element, we have to create the real constant. So click on link 34 and click OK. Give the area value 1 meter square and click OK now. Now close this. Go for material property, material model. Here there are 4 walls and on each surfaces, that is inside surface and outside surface, there is a convection taking place. Therefore we have to create 4 plus 2, that is 6 models. Starting from the left side, this is the inner surface, right? That's why this is the first model, this is second, this is third, this is fourth, this is fifth and this is sixth. I am assigning for each model its separate unique properties. These are the properties. I am assigning it now. This is the first model and for that convective heat transfer coefficient is 6 watt per meter square degree Celsius. So material model number 1, thermal, convection, and value is 6. Click OK. Now go to material, new model, model number 2, model ID 2 and click OK. This is the gypsum material. For that gypsum material we have the conductivity 0.176. So give the value conductivity isotropic 0.176 and click OK. Now create the third model, which is fiberglass. For that we have the conductivity 0.036. So give the value for material number 3, 0.036 and click OK. Now again create the fourth model, and fourth model is polywood. For polywood we have the conductivity 0.115. Give the value and click OK. Go to new model, create the fifth model, and fifth model is hardboard. For that, conductivity is 0.215. Give the conductivity value 0.215 and click OK. Again, there is a convection on the outer surface, and with a convective heat transfer coefficient of 10 watt per meter square degree Celsius. Give that as the sixth model, model number 6, and here convection, that is 10, and click OK. Now you have to remember all these things. We have assigned two elements, conduction 33 and conduction 34, that is link 33 and link 34. For each elements we have assigned real constant, and we have assigned 6 model material properties. Now go for modeling, create nodes in ActiveCS. Always first create the first node at origin. Simply click apply. The first node will be created at the origin. Now the thickness for wall is given, but the thickness here it is not specified. You can assume it any value. I am taking 1 mm. This is the first node and this is the second node. Second node is at a distance of 1 mm. So give the value 1 exponential minus 3. Since all the dimensions are in meter, that is for conductivity and the heat convective coefficient, I am keeping the dimensions in meters only. Give the value 1 exponential minus 3, click apply. Now this is the third node, this is fourth node, this is fifth, this is sixth, and this is seventh. Now the third node is at 12 plus 1, that is 13 mm. So here add 12 exponential minus 3 and click apply. Third node will be created. Then plus 75 exponential minus 3. Click apply. Then plus 20 exponential minus 3. Click apply. Now plus 20 exponential minus 3 and click apply. Now we have to create the last node. It is plus 1 mm exponential minus 3. Give the value as 13 exponential minus 3 plus 75 exponential minus 3 plus 40 exponential minus 3 plus 1 exponential minus 3 and click OK. Now the seventh element is created, seventh node is created. Now go for elements, element attributes. Here from first node to second node there is a convection taking place. For convection we have to select the element, that is convection 34, that is link 34, and for that link 34 we assign the real constant at set number 2 and the model number is 1. So here select link 34 and for that link 34 material number is 1 and real constant set number is 2 and click OK. Now go to auto number in the elements through node. Here it is not visible, but just simply click on the left side and right side. You can see the 2 number, right? On this just simply click, the element will be created there. Click OK. And now the first element is created. We have to create the second element, that is the gypsum wall. So for that gypsum wall there is a conduction taking place. So go to element attributes. For conduction it is link 33 and for the second material number is 2 and real constant set number for link 33 is 1 and click OK. Now go for through nodes. Here just click below the 2 and below the 3 and click OK. Here you can see that element is created. Now go for element attributes. For fiber wall it is link 33 but material number for fiber wall is 3. So select 3 here, and real constant for link 33 is 1 and click OK. Again go to through node, node 3 to node 4, click OK. Element attributes, link 33, fourth model, real constant set 1, click OK. Through node, from 4th node to 5th node, click OK. Element attributes again, but here 5th material number, click OK. Through nodes 5 to 6, OK. Now material attributes 6, but here convection is taking place, so change it for link 34, and for convection real constant set is 2 and click OK. Now go for through nodes, select 6 and 7, click OK. Now the element is created. Since we created the nodes and elements, there is no need to do the meshing. Just close this, go for solution part. In that, go for analysis type, new analysis, steady state, click OK. Here come for define loads, apply, thermal, temperature, on nodes. Here T1 is 20 degrees Celsius and it is acting on the inner surface. Therefore click on first node and click OK. Give the temperature value 20 degrees Celsius, 20, click OK. Now go for again on node in the temperature. There is a outside temperature of minus 10 degree. So click on 7th node and click OK. Give the temperature value minus 10 and click OK. Now we have assigned the temperatures also. Solve this. Go for solve current ls, click OK. Click yes here. Now the solution is done. Now go for post processor, read result, last set, plot result. Sorry, you can go for list result also. Nodal solution, DOF solution, nodal temperatures, click OK. Now this is the nodal temperature. Here we can compare this to the theoretical solution. Just go for theoretical solution part. Here you can see that T1 is 20 degree, that is the inside temperature. T2 is 18.13. Here it is also 18.13. And T3 is 17.37. T3 is 17.368. It's approximately equal. T4 is minus 5.9. Here also it is minus 5.9. T5 is minus 7.8. Here it is also minus 7.8. T6 is minus 8.8. Here also it is minus 8.8. And T7 is, as it is given, it is minus 10 degree Celsius. Now the temperature is perfect. Let us see this 11.17, that is heat transfer. 11.17. Let us check this. Close this. Go for element table. To see the heat transfer, go for element table, define table. Click on add. Here type H-trans, that is heat transfer, and by sequence number SMISE 1 and click OK. Close this. Here itself, in the element table itself, go to list element table and select H-trans and click OK. 11.17 heat transfer. It is also same as in the theoretical solution. Now the solution is perfect. Okay, thank you for watching my video. If you find my video helpful, don't forget to like, share and subscribe. If you have any suggestion, please leave the comment. Stay tuned for my channel for further videos. Thank you for watching my video. Have a great day.